In Chapter 12, we started into an intro to trigonometry. So, trigonometry is dealing with triangles and the special relationships that sides have to angles and how we can use those relationships to find some missing parts. So, I'm going to start us off with just a brief definition of the 6 trig functions that we covered. So, if you want to do well, one easy way to do that would be to remember SOHCAHTOA. Alright, so is sine of the angle that you're talking about. I'm just going to call it theta. Sine of theta is the opposite side over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over adjacent side. Alright, so in any triangle, I should be able to find the sides that I'm talking about if it's a right triangle. So it being a right triangle, that allows us to name one of the sides a hypotenuse. The hypotenuse is always going to be opposite of the right angle, and the opposite side is going to be across the triangle, and the adjacent side is going to be one of the sides that creates the angle we're talking about or is next to it that is not the hypotenuse. So the hypotenuse and the adjacent side, they make up this angle. However, the hypotenuse already has a name. So the sine, cosine, and tangent, SOHCAHTOA, those make up 3 of our trig functions, and we also have the cosecant, the secant, and the cotangent. And these ones have relationships with sine, cosine, and tangent. What you guys said in class is the C's and S's, they go together, opposites attract, I guess. You guys said that they were dating. So the cosecant, if I don't have this nice fraction that I can flip, which it is the hypotenuse over opposite, so you can kind of see its relationship with sine. If you don't have a nice fraction that you can flip, you can take the reciprocal of sine, so 1 over the sine of theta. And the secant is going to have the same kind of relationship, the hypotenuse over adjacent, or 1 over cosine of theta. And cotangent is the adjacent over the opposite side, and that will be 1 over the tangent of theta. So those are your 6 trig functions, and you need to be able to figure out what sides are what according to the angle that they're asking about and these 6 trig functions. If you are only given 2 sides, do not forget the Pythagorean theorem. You should be able to find a third side using the 2 that you have. So I'm going to write out the special right triangles that are written on page 646. So we have a 30, 60, 90, so this is a 30, 60, 90, and a 45, 45, 90. There are a couple of special relationships that you guys would have learned in geometry, and those are for a 30, 60, 90, I have a short leg. I'm just going to say it has the value of x. And a long leg. So the long leg is always going to be the short leg. Is always going to be the short leg times radical 3. So this would be x radical 3. And the hypotenuse in a 30, 60, 90 is always going to be 2 times the short leg. And for a 45, 45, you should know if there's 45 degrees up here, there's going to be 45 degrees here, and that means those angles are congruent, so their opposite sides are congruent as well. That's a dead giveaway, and that makes it really easy to find another side if they don't explicitly give you that value. So the relationship here is if one of the legs is x, you know the other leg is x. And you can find the hypotenuse by the Pythagorean theorem. However, I'll give you the shortcut. version here. So your hypotenuse is going to be the leg, which both of the legs are the same, so it doesn't matter which one you choose, times radical 2. Those are the special right triangles. And we have this chart at the top of page 646 for the sine, cosine, and tangent of 30, 60, and 45. And normally it is written 30, 60, 45, not 30, 45, 60 in order, because you can kind of see the relationships that happen on the chart. So the sine of 30 degrees is 1/2. The cosine of 60 degrees is 1/2. And you can actually find that out by doing your sine and cosine of those angles. You're using the same exact sides. That's why those values come out to the same proportion. Alright, to the same ratio. The cosine of 30 is radical 3 over 2. The sine of 60 is radical 3 over 2. And I did tell you guys that the tangent of any angle is equal to its sine over its cosine. So if you completely forget this third column, you could take your sine value over your cosine value and play around with the fractions and do a keep, change, flip. So your tangent of 30 is going to end up being radical 3 over 3, because we never want 1 over radical 3. When we were dealing with the radicals, you know that I shouldn't have square roots underneath of my fraction bar. And the tangent of 60 is going to be the square root of 3. So now I can mess with my 45 degrees, and the sine and cosine are going to be the exact same. And since sine divided by cosine is itself, it will be 1. So you guys were to memorize this so that we can easily just plug in some values and solve for a missing side if we had these special right triangles. So I'm going to work through an example of that. Okay, this problem says it wants the exact, not rounded, the exact values of x and y. So that means I need to be seeing funny things like square roots. Alright, so in order to solve for x, let's go ahead and look at the side that I have according to the angle that I have. So I have the side opposite. So I'm going to use, let's go ahead and use tangent. For example, the tangent of 60 degrees is equal to 3 radical 3 over x. Alright, so opposite over adjacent, and I know from my chart that the tangent of 60 degrees, if I refer back, tangent of 60 degrees is radical 3. I have that memorized. Alright, so I can sub that in, 3 radical 3 over x. In order to solve for x, you guys normally cross multiply and divide, so I'll put the left side over 1. So this is x square root of 3 is equal to 3 radical 3 times 1, which is just 3 radical 3, and then I divide by the square root of 3. Cancels out on the left side. X equals 3. And if you guys knew your special relationships from geometry, you would know that the long leg is equal to the short leg times radical 3. So you could have done long equals short times radical 3, and you knew that your long was 3 radical 3, so that was short times radical 3, and that would have just been a little bit easier had you known that relationship. But you can always set it up this way, and you'll need to use these functions anyways. So now I need to continue on to part 2 and solve for y. So I have x, I need to solve for y. And if I have x equals 3 now, I'm going to go ahead and use that value instead of that square root, because I think it's going to work out a little bit nicer. So that means I have my adjacent side, so let's go for the cosine of 60 degrees is equal to 3 over y, so my side adjacent over my hypotenuse, and I'll rearrange. First I'm going to substitute for the cosine of 60, which I know cosine of 60 is 1/2. So 1/2 is equal to 3 over y, and we can go ahead and cross multiply. Y equals 6. Boom. Done. Let's move on to the next concept. So in 12.2, we discussed a whole bunch about angles and where they're at and how we can use these trig functions. So first and foremost, you need to know the language initial and terminal in standard position. So if it says to draw an angle in standard position, then I need to know that I am starting on the positive x-axis. Alright, so I'm going to work out number 2 on your packet. It wants me to sketch the angle with a terminal side. Alright, so negative 420 degrees. So if I'm going negative, I'm going to be circling around this way. I'm going to actually make my graph a little bit smaller. Alright, I'm going to be circling clockwise for negative. Alright, a full circle gets me to 360 degrees. If I go a full 90 more, that's 360 plus 90, which is equal to 450. So that is not quite there. So how do I get from 360 here, keep in mind it's negative 360, to 420? I need to do 60 more, so I should be 2/3 of the way. And do not forget your arrow that tells me whether it's negative or positive. That is negative 420 degrees. And that's how you would draw it. Now I'm going to work out an example, like 9 through 12 on your packet. It says, here's a point, negative 4, 3. Find all 3 main trig functions. So evaluate sine, cosine, and tangent of theta. So first what you're going to want to do is graph it. So I'm going to move my graph a little bit. Alright, negative 1, 2, 3, 4, and positive 1, 2, 3. Alright, here's my point. So if I draw my nice triangle, the theta I'm talking about is this inside angle here. So I know this is negative 4, the length of this is negative 4, and it's positive 3. If I use my Pythagorean theorem, I know that the hypotenuse here is 5. So, in order to find the sine of this angle, sine of the blue angle, I need to take sine of theta, side opposite over hypotenuse. The cosine of theta is the side adjacent, negative 4/5, and the tangent of theta is going to be opposite over the adjacent. And if you guys remember, all students take calculus. This tells you which values are positive, so the sign should have been positive, and it was. All of the other ones were negative, so that worked out for me. And that's going to carry into our next problem. So determine whether the trig function is positive or negative. So really, you just need to figure out, well, where is this angle? Cosine of 265. So if I'm going positive, this is 90, this is 180, and this is 270. So I know that I'm going to be right in here in the third quadrant. All students take. So tangent is the only one that's positive, so cosine is going to be negative. And last but certainly not least on this section, it says, use a calculator. Evaluate the function. So cosine, all you would do is type in cosine of 300 degrees. However, what if it said secant of 300? There is no secant button. What you would do, since secant is the inverse, you would type in 1 divided by, or sorry, not the inverse, the reciprocal. Reciprocal of cosine you take that value. That's why they have the relationship. It works out very nicely. And then it says rounded, so make sure that you're rounding properly. In 12.4, all we covered was the the law of signs, which you can set up a couple of different ways. So you can have your sides on top over the signs, or the angles, signs over the signs, sides over the signs, or you can put your angles on the top and take the sign over the side values. What was interesting about this section was that it didn't have to be a right triangle, and you guys had to find the third angle if they only gave you two. So you had to remember that all triangles add up to 180 degrees. So you would set up these proportions depending on the pieces of information that you had, and you would be able to cross multiply and divide. I'm not going to go into a specific example with these, as I have already worked out an example that I use cross multiplying and dividing. I will go into one example in which you have to find an angle using inverse sign. Okay, so in this example I'm given two legs and one angle. Sometimes you're given two angles and one leg. So this one involves just a little bit more work, just one more step than the other type of example. So that's why I want to work this one out. So what I have are my A's and my B's. So what I'm going to try to do is put my missing variable on top. So sine of B over B is going to equal the sine of A over A. And if I fill in the sine of x degrees over 15 is equal to the sine of 37 divided by 11. I always suggest that you put your unknown on top, just because sometimes it makes it easier to isolate. So you're just able to multiply everything else onto the other side instead of dividing in these types of problems. So in order to isolate my x, I multiply each side by 15. Right? So I get sine of x. I had to tell you guys it's very important that you know it's not x, it's the sine of x. Because a lot of people were telling me, oh, that angle is 0.85. Does it look 0.85 degrees? So make sure your answers seem a little bit logical. So I'm going to go ahead and just type in so that you can see the decimal that it comes out to. Alright, so it should come out to 0.8206568498 on and on. Alright, so it's a small decimal. It should be a bigger angle than that, otherwise this triangle wouldn't look like that. So what I need to do is I need to take the inverse sign of both sides. So sine inverse, make sure everything's in parentheses. Alright, sine and sine inverse, they are reciprocals of, or sorry, they're not reciprocals, they're inverses, so they multiply to 1, so you're left with x. And what we want to do is type in sine inverse of 15 times sine of 37 divided by 11. So the sine inverse, it should come out to about 55 degrees if I round it, which that looks about right. So that would be 55. So really my main point on these problems and the law of signs in general is it's going to be a little bit easier to solve for a side length. Do not use the Pythagorean theorem, as these are not right triangles. If you're trying to find an angle, it's just one more step by taking the inverse. Alright, I'm going to move on to our last section, which was 13.1. And we just reviewed the distance formula and the midpoint formula. So I'm going to go ahead and pull those up now with a couple of examples. Alright, so if I have to find the distance or midpoint, all I have to do is plug in the formula. We did prove in class by rearranging these x's and rearranging the y's that it actually didn't matter the order that you put it or subtract, as long as you have the x's with the x's and the y's with the y's. And it always should come out positive, because whatever you square, if you square a positive number, it ends up positive. If you square a negative number, it ends up positive. And then for midpoint, we discussed how if we're adding values and dividing by 2, what we're doing is we're averaging. So if we are averaging, you're trying to get that value in the middle. So it should make sense that it's going to be the midpoint. So I'm going to find the distance and midpoint of these 2 points given. So I want to put my x's and subtract them. So I'll just do 3 minus 7 squared plus 1 minus, be very careful with your negative signs, 1 minus negative 1 squared gives me the square root of negative 4 squared plus 2 squared, square root of 16 plus 4. This comes out to the square root of 20. And I do know that the square root of 20 is about 4.5. However, I did a little bit of review and told you guys that this could break into the square root of 4 times the square root of 5, which is 2 radical 5. But I would probably ask you guys to round and give me 4.47. And the midpoint, I need to go ahead and add my x values. 3 plus 7, an average, and 1 plus negative 1, an average. So that's 10 over 2, which is 5, and 0 over 2. 0 divided by anything is 0, so this is my midpoint. And my distance is 2 radical 5, or 4.47.